Okay, good evening, everyone. I trust you're doing well. I trust your day went well. Okay, I can see Brian is here, Genesis, and Blessing. It looks like the three of you joined. So who is the first person? Uh, okay, Genesis say me, Brian says me. Okay, I wouldn't know. The three of you are carrying the number one batch, so I'll find out. So let's give others some time to join in, maybe like in 2 minutes. Okay, can you guys see my screen? Okay, Brian. Okay, so let's give others few minutes to join in. In the next 1 or 2 minutes, I will start. Give me a second, please. The subject is chemistry. Who is Christ in View Ministry Media? I'm just seeing you for the first time. Can you identify yourself? Christ in View Ministry Media. Can you identify yourself? Christ in View Ministry Media. Can you tell me what your name is, please? She may not be new, she may be using another. I just want to know. Okay, she's Angel. Is that the same person as Angel Fortune? Sorry. Can't see. No, we are not waiting for others. I'm the one that is distracted. Okay, are we ready? So if you're ready, kindly indicate yes, I'm ready. Yes, I'm ready. Yes, I'm ready. If you are ready, can you indicate that you are ready? Okay, good. Okay, good. Um, so today we are looking at chemistry, and the topic we are looking at is atoms, molecules, and ions. Now, first of all, I want to say this, and very important for all of us to know that atoms, molecules, and ions are the building block of matter. Atoms, molecules, and ions are the building block of matter. It's affecting this thing.
I don't know what to do.
Okay. I don't know. Maybe. Oh, it's the join. Um. Okay. I need you guys to give me some. Okay, building block. Now, in the same way, if it happens, then I know I will go and check. In the same way, that cell is the building block of life. So when they say what is the big unit of life, you say it is cell in biology. But in chemistry, the building block of matter is atoms, molecules, and ions. So what that means is that matter is a buildup of atoms or molecules or ions or a combination of all of them. Now, you're now beginning to enter chemistry proper. So I like you to give me your attention. So we are going to start with, I already mentioned that the basic unit of matter is atoms. Okay, please, I like to check. Okay, okay. Can you hear me? Please, if you can hear me, indicate, please. Okay, that's good. So just like I was saying, I said that the building block of matter. I hope you guys can. Which of the following are the building block of matter? So you know that the building block of matter are atoms, molecules, and ions. So now we want to go into understanding the difference between atoms, molecules, and ions. My screen. What is wrong? Okay. Okay. Can you guys see my screen now? Okay. So let's go into now. We start with atoms. Now, atoms is the smallest particle of an element capable of participating in a chemical reaction without losing its identity. Is the smallest particle of an element, the smallest that is capable of participating in a chemical reaction without losing its identity. Okay, that's very important for you to know. Okay, so now I would like to say something here. You know, I think it was the second or third class, I can't remember exactly, that I taught you guys something about elements. And I showed you that we have about 105 elements. Now, the smallest particle of an element is called the atom. For example, oxygen elements, oxygen element is not the same thing as oxygen. Okay, is the same thing as oxygen atom. So when I say oxygen element and I say oxygen atom, I'm not saying different thing. It's just like saying um, I'm trying to look for a better way to put it. Okay, but that's by the way. That's by the way. Now, so an atom is the smallest unit. Like if I want to write oxygen atom, for example, I don't know why my pen is not giving me what I want. Oxygen atom, the symbol is O. Then let me say nitrogen atom. Atom, the symbol for nitrogen is N. So the simple thing you should know for now, I will still explain it as we continue further. The main thing you should know for now is that an atom is the smallest part of an element that can still retain or that can still take part in a chemical reaction without losing its identity. The smallest part of an element that can still take part in a chemical reaction without losing its identity. Okay? Now, but in the case of molecule, because I'm going to explain, molecule, based on what I have here, molecule is the smallest chemically stable unit of a substance capable of an independent standard. Okay, well, you may not have this definition in school. Instead, you can say molecule is the smallest part. You can write this one. Molecule is the smallest part of a substance. You can put in brackets element or compound that can take part that can take part in a chemical reaction and still retain so a molecule is the smallest part of a substance, and that substance can be an element or a compound that can take part in a chemical reaction and still retain its property. Okay, for some of your questions, I will still get to explain that. But atom and element are not exactly the same thing, but they are the same thing. If I say, keep this bag of mangoes, it's just like elements. Everything inside that bag are mangoes. But if I take one mango, that's the smallest unit, I will call it an atom. So an element is just like a general classification. Atom is the smallest unit of that classification, the smallest member. If, for example, I want to teach about ants in biology, you know there are many ants. So if I pick one ant, that one ant out of the many ants is like the atom, the smallest part of an element. Okay, there are many other ants, but I chose to pick one. So that's what an atom is. That's the difference. Element is made up of atoms. Yes, you can say that. Elements, sometimes we use them interchangeably. I can say oxygen element. I can say oxygen atom. Okay? But I'm going to tell you the difference very soon. Very, very soon. You are going to understand something very soon. Then for the person that asks for, okay. Yeah. Now, the definition, if you notice, the definition for atoms and molecules are alike. Now, but this is the difference. One of the difference is that in atoms, we say atom is the smallest part of an element. But molecule is the smallest part of a substance. It's not the same thing. A molecule can be an element, can be a compound, but an atom is simply an element. And let me give you the difference. Let me show you the difference now. Okay, so now I want you guys to listen. I want to explain something. Now, in nature, let me use oxygen for an example. I want to use oxygen for an example. In nature, oxygen does not exist as O. In nature, oxygen exists as O2. If you are writing oxygen in a chemical reaction, you don't say O, you say O2. What that means is, in this case now, this is a molecule. Okay, let me say element. Oxygen element. Oxygen element can be an atom or a molecule. Here it is a molecule, but here it is an atom. Here it is a molecule, but here it is an atom. An atom because it's just O. But in nature, oxygen exists as O2. Another example is nitrogen. Nitrogen in nature exists as N2. So if I tell you, write the formula for nitrogen gas, you're going to write it as N2. and that is a molecule. But nitrogen atom is just N. Atom is just the smallest part, N. But as a molecule, it is N2. So some elements exist as a molecule, and why some of them exist as an atom. I don't know if you understand that. If you understand what I just said, let me know. If you don't, let me know. So there is a difference between what happens in nature. Okay? So, good. Good. So that's the difference between elements and between atoms and molecule. Both of them can be elements. Both of them are elements, but one of them is atom, the other one is a molecule. Okay, now I want to say this, that a molecule itself can be an element, can also be a compound. Now, this is the next thing I want to say. I'm glad that you guys understand that. This is the next thing I want to say. Molecule can be an element. Molecule can be a compound. I'm seeing that only 9 persons has joined. I wonder why the rest of you are not here. Okay. Now, listen. Molecule can be either an element or a compound. And let me explain. When it is the same atom, it is a molecule. Like, for example, nitrogen element, oxygen molecule. Let me say chlorine. All these are elements, but they are molecule because two atoms coming together makes up a molecule. But compound means that they are different atoms, like hydrogen chloride, like carbon 4 oxide, like sodium chloride. These are compounds, and the reason why we call them, they are compounds, they're also molecule, but they contain two different elements combining together. When 2 or 3 more elements combine together, you call them a compound. But when it is the same element, then it is just element. Whether it is an element or a compound, both of them are molecules. As long as molecule is equal to atom plus atom plus atom, no matter the number of atoms. Okay? Look at this. This is carbon atom. This is calcium atom. This is oxygen atom. Now, I need one carbon atom to combine with one calcium atom to combine with 3 oxygen atom to give me what we call calcium carbonate. If you have ever heard of limestone, this is the formula for limestone. So limestone is a compound, that's a molecule, but contains calcium atom, 1 calcium atom, 1 carbon atom, and 3 oxygen atoms. Do we understand that? Okay. 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 So now listen to what I said. I'm trying to differentiate between elements, molecule and atoms. And the simple way I can differentiate it is that a molecule is a combination of 2 or more atoms. A molecule is a combination of 2 or more atoms. That means if 2 or more atoms come together, you will form a molecule. Look at this again. I'm going to use another example. I want to look for something common. Okay, look at water. Water is a molecule. Water is also a compound. The formula for water is H2O. Now, it is a molecule because it contains three atoms. That means hydrogen plus another oxygen, giving me water. That's why it is a molecule. Molecule is when two or more elements come together. Then we can call this molecule a compound because the elements are not the same. The elements are not the same. There is hydrogen, there is oxygen, so it is a compound. Now, but look at something like this. Oxygen. Oxygen is a molecule. That's if I write it as O2. It is not a compound, it is an element. I cannot call oxygen a compound. The reason why I cannot call oxygen a compound because oxygen contains only one atom, one type of atom. So it is a molecule because it is oxygen plus oxygen will give me oxygen molecule. But it is not a compound because it's the same element. It is oxygen element, the same element. Does that make sense? Does that make sense? Yes, calcium carbonate. Okay, my screen now. You can't see my screen. How about now? Can you see my screen now? Okay, you can see my screen. Good. Okay, so now there is another compound. Sometimes we call it chalk. And this marble is a molecule and it is also a compound. The formula for this, just like water is H2O, the formula for marble is CaCO3. So it is a molecule because you have one calcium, one carbon. This element is carbon. Then you have three oxygen. So one calcium combined with one carbon combined with three oxygen to give me calcium carbonate, CaCO3. That's why it is a molecule. It is a compound because the elements are different. The atoms are different. Calcium, carbon, and oxygen are different atoms. So that's why we call it a compound. Can you see the difference? Do you guys understand it now? Hello, do we understand? CaCO3 is also called limestone, marble, chalk. These are different names for the same thing. But its IUPAC name is calcium carbonate, and I will explain that later. That's a topic on its own. How to write compounds. I'm going to teach you guys that. Is a topic. But we are taking it one step at a time. Many of you are seeing chemistry for the first time. No, two things cannot have the same formula, but they can have different names. That's for Genesis. Two things cannot have the same formulas, but they can have different names. Okay. I want to continue. I hope I can. Tony George, come again where? Where? How? Okay, so now listen again. I want to write different things and explain. Oh, so look at all these things I've written. I want to now. So watch my classification to help you know the difference. Are we ready? If you are ready, let me know. Okay, Bukola, please don't come late again. But the formula for oxygen is O, but it exists as O2 in nature. It exists as O2 in nature. Okay, now listen. This one is an atom. You can also call it an element. It is oxygen element, and it is atom because only one atom of oxygen you have here. This one is an element, but also a molecule. A molecule because two atoms come together to form it. That's why it is called a molecule. Before I continue, do you guys understand the first two? Chinelo, it looks like you came late. I don't want us to be dragging us back. Just follow through. Just listen. The video will be available for you to watch. So, do you guys understand the first two? Atom and the first one is an atom and also an element. The second one, nitrogen, is an element but a molecule. So, Chinelo, simply put, when two atoms come together, you form a molecule. When two atoms come together, you form a molecule. When two or more atoms come together, you form a molecule. So this first one, I cannot call this a molecule. No, it's only one single atom. I can say oxygen atom, oxygen element. I'm correct. This one is nitrogen element, but this element is a molecule. There's a difference between N2 and N. If it was N, then I will call it an element. But in this case now, it is an atom. So an atom is the smallest unit, but a molecule is when two atoms come together, when two atoms combine together. Then look at this one, HCl. This is a molecule because two atoms come together. I will call it is also a compound because the atoms are different. So molecules whose atoms are different is called a compound. Molecules whose atoms are different is called a compound. This one here is also a molecule because it contains three oxygen atoms, three, O3. The name of this is called ozone. I know some of you should have heard ozone. You should have heard, ozone. Then this one is calcium. This is an element. It's also an atom. It's the smallest, it's the simplest. Okay. Do I continue? Are you guys following? Do I continue? And like I said, don't worry about the naming. We will soon treat naming of compounds very soon. That is very important in chemistry. I'm waiting for you guys to say something. Genesis, when atoms come together, they make a molecule. And a molecule can either be an element or a compound. When two or more atoms come together, they form a molecule. But a molecule can be an element, a molecule can also be a compound. If it is the same, you call it element. But if the atoms are different, you call it compound. Yes, we can call O3 an element because it's made up of oxygen element. HCl. HCl is two different elements now. I mean, two different atoms, hydrogen and chlorine. They come together to form HCl. So you can call it a molecule. It's a molecule and is also a compound because they are different. So look at this one. This is a molecule and also a compound. This is a molecule and also a compound. This is an atom, an element. Of course, atom is the smallest unit of an element. So an atom is always an element. This one is not an atom. This is a molecule because it's O2 and it is an element. You can ask your questions. Genesis, what do you mean by can we have atoms and molecules? How do you mean? What is the difference between proton and atom? Proton is one of the units of atom. Atom, you can still break atom down. Can you see my screen now? So atom is made up of protons, neutrons, and electrons. Atom is made up of proton, neutrons, and electrons. Then somebody asks, what is O2? I have explained this before. O2 is oxygen molecule. O is oxygen atom. But both of them represent oxygen elements. Okay, you can't see my screen. Can you see my screen now? Okay, for Bukola that just asked, I explained something that oxygen O2 is oxygen molecule, but just O, a single O is oxygen atom. Both of them represent oxygen elements. They both represent oxygen elements. I hope that is clear. And I believe I've been able to differentiate between atoms and molecules. When atoms come together, they form a molecule. When atoms come together, they form a molecule. Okay, okay. So I guess I can move on. Okay, very good. Okay. Now, the third part of is what we call ions and radicals. So now look at this. An ion is an atom or group of atoms bearing an electrical charge due to loss or gain of electrons. An ion is an atom or group of atoms that possess or that bears an electrical charge due to loss and gain of electrons. So when we say ion, this ion we are talking about is ION, not IRON. IRON is Fe, is a metal, and the formula is Fe. But ION, anything that carries ion, can either be a positive charge or a negative charge. So an ion must carry charge. That's why it is called an ion. So even though ion and ion, they have the same pronunciation, but they don't mean the same thing. IRON is a metal, and the formula is Fe. I just wrote that. But ION is a charge. It must carry a charge. A charge can be positive or negative. There are two types of charges. Let me write. So there are two types of charges. We have positive charge and we have negative charge. Now, a positive charge is formed when a substance loses electron. A positive charge is formed when a substance loses electron. Are you guys following? Okay, very good. So now let me say this, even though I'm going to mention this later. An atom is made up of three subparticles. Proton, neutron, electron. So now, even though we are going to look at that later, an atom can be split into protons, neutrons, and electrons. Now, this is just a kind of diagram. Okay, I think I have a diagram here. This is what it looks like. I believe everybody can see this diagram. So this part here, everything here is called nucleus. We call it a nucleus. Inside that nucleus, you have protons and neutrons. That's inside this nucleus. But electrons are just around it. The same way planets are around the sun. Are we following? Yes, Blessing, you are correct. Atom is the smallest part of an element, but it can still simplify it further. Protons, remember the definition I gave for atoms, is the smallest part of an element that can take part in a chemical reaction. Protons cannot take part in a chemical reaction. Electron cannot take part in a chemical reaction. Neutrons cannot take part in a chemical reaction. Just like in biology, the smallest unit of life is the cell. But inside the cell, we have many organelles. I heard Mr. Mike teaching you guys biology. It has many organelles. Inside the cell, you have the nucleus, you have the cytoplasm, you have the reticulum, and so on and so forth. Do you understand, Blessing? I'm actually waiting for a response before I continue. I like to be sure you understand. Yes, the red and the blue ones are protons and neutrons. The red and the blue ones are protons and neutrons, correct? So cell is the simplest unit of life, but cell itself has different organelles, has different components. Yeah. So that's the same thing. Atom is the smallest unit of an element, but atom can also have different components, which are electrons, protons, and neutrons. Of course, they can't take part. It's just like the three of them, protons, neutrons, and electrons, help the atom to take part in a reaction, but they themselves cannot take part in the reaction. They cannot exist alone. Okay, for example, now you as a human being, you have your heart. Can your heart exist alone? Can it go somewhere? Can it think? But your heart needs to cooperate with the brain, needs to cooperate with your legs, your hand, different members of your body to function as a body. So electrons, protons, and neutrons cannot function on their own, but they come together to act as one. Genesis, where did you hear constant? I believe that I've answered a lot of your questions. I think I should continue. So now, The reason why I talked about the component of atom is so that you can see that electrons is what is involved. When a substance loses electron, it becomes positively charged. When that substance gains electrons, it becomes negatively charged, right? So, and I just mentioned to us that these ions, we also have, okay, let me put it this way. Please note, positive ions are called cations. Negative ions are called anions. So kindly note that the positive ions, we call them cations. The negative ions, we call them anions. That's very important. Are you guys following? If you're following, please let me know. Anions is ANIONS. ANIONS. Let me type it on the chat box. Yes, Gina, they are gotten from Latin and Greek. So, for you to be under me and not know chemistry, it will be a very big problem. Oh. For you to be under me and not know chemistry, it's going to be a very big problem. Genesis, I don't know if it is from Greek or from Latin. I don't know which one. Because my screen. Okay, can you see my screen now? Okay, good. Now, I want you guys to look at this. In chemistry, you call this one here, you call it sodium atom. But this one, you call it sodium ion because it carries a positive charge. These three are oxygen. We will call this oxygen atom. We will call this oxygen molecule. But this one, we'll call it oxygen ion. Can you see what I'm doing? Can you see what I'm doing? I'm trying to differentiate them. So in chemistry, don't call something else. I thought oh my God, this screen. By next class, I will solve this screen problem once and for all. Yeah, oxygen is meant to be 2 minus. Later, you are going to know why. Oxygen can gain 2 electrons. Oxygen has the ability to gain 2 electrons. That's why it is -2. Sodium has the ability to lose 1 electron. That's why it is +1. So let me write more. Are you seeing? So notice that chlorine is just -1, but oxygen is -2. The reason is because chlorine can gain only 1 electron. Later, as we progress, you are going to know why. But oxygen can gain 2 electrons, so it is -2, O2 minus, oxygen ion. Okay, so I believe with this, you can see the difference between ion, atom, molecule, right? I'm waiting for a response. Only one person is saying something. What of the others? I need to see your comments to continue. Okay, good. So, are you guys done writing? Because so I can move to the next thing. Are you done writing? Okay, I want to see if I can get something for us to work with, just to test us a bit before we continue. But I want to believe that what I have done makes sense. Okay, well, okay, I think I think I will just give it as homework, as assignments. Okay, I will drop it for us. Now, there is something called poly. Now, I want to ask from that name, polyatomic ions. From that name, polyatomic ions, can somebody tell me what you think it means? From its name, polyatomic ions. Okay, Genesis says more than two ions. Okay, that's good. Any other person? From the name polyatomic ion, what do you think? In a layman's language. I'm waiting for the others. Okay, a group of two or more atoms bounded together. Okay, that's a good one. Ions that have more than two atoms. Blessing gave the correct answer. Ions that have more than one atom, actually, not more than two. So, yeah, there are many. For example, there are some ions that are like that in chemistry. I will explain that later. You can have OH. This is an example of polyatomic. Plenty atoms come together to have an ion. Like this one, the name is hydroxide ion. Don't worry if you don't know it. We are growing. This one is called nitrate ion, carbonate ion. Actually, the full name is trioxocarbonate 4 ion. Why this one is trioxonitrate 5 ion. This one is hydroxide ion. This is just very few examples. There are many in chemistry. There are many in chemistry. So welcome back, Bukola. So there are many in chemistry. An ion that has more than one atom is called a polyatomic ion. An ion that has more than one atom is called a polyatomic ion. And how you know is that the element is more than one. The ion has more than one atom. Like this first one here. This one has oxygen and hydrogen. This one has nitrogen and 3 oxygen. This one has carbon and 3 oxygen. And they are ion because they carry charge. Remember, they are called ions because they carry charge. Negative charge, negative charge. This is negative charge -2. I hope that makes sense. I need your response. Okay, Genesis and Tony George, what are you saying no for? Okay, Darasimi, nice one. Okay, to repeat myself again for the last time, polyatomic ion is an ion. Remember, an ion must carry either a positive charge or a negative charge. So polyatomic ion is an ion that has more than one atom in it. That's simply the definition. I don't think it's a big deal. And I'm just giving us the examples like OH ion, NO3 ion, CO3 ion, 2 minus. Even something like this, ammonium, NH4 plus. This is also a polyatomic ion. This one has 5 elements, 5 atoms, 1 nitrogen and 4 hydrogens. This one has 4, 1 carbon and 3 oxygens. This one has 4, 1 nitrogen and 3 oxygen. This one has 2, 1 oxygen and 1 hydrogen. All together makes up an ion. And each of them have a name. For now, we are not going to bother ourselves with it. But, okay, I'm glad you understand now, Tony. We're not going to bother ourselves with it, but you should know that they exist. For now, you just need to know that they exist. So, polyatomic ions. Is that clear? Genesis is not saying anything. So we are done with this. Okay, I have one small exercise for us to do together. Okay, maybe I'm going to give the exercise as an assignment. Yeah. Okay, look at this. Tell me what you think about this. Okay. Um say something, a little class exercise. Say something about all the things I just wrote now. Say something about them in the light of what I'm teaching you guys. Quickly. I'm waiting. I'm waiting. No, S is sulfur. Yeah, blessing, correct. Genesis, that's a mistake. Okay. 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 Ugochukwu, yeah. AG is not argon. AG is silver. Genesis, that's not correct. Okay. I'm happy with our responses. Let me answer us. Let me give the answers. I'm happy with our responses. So this is an atom. So that's it. Okay. Tony George, ClO3 is not a molecule because of that minus sign. That minus sign makes it an ion, not a molecule. And F is fluorine. F is fluorine. If it is just simply F is atom. The name of this atom is called fluorine. You see why I told you guys that you guys should go and learn the first 20 elements. Very important. Go and learn first 20 elements. I wrote it down here before, and you have to go and learn it. Ami, your answer is perfect. Your answer is perfect, but you didn't get the second to the last one. The second to the last one is anion. Then Genesis, I saw you write. Okay, I can't see what you wrote, but I hope you understand now. Yes, the last one is a polyatomic ion. If you have any objection, state. Say, yes, sir, I have an objection. Me now, can you hear me? Okay, can you guys hear me? Okay. So, it's an The type of ion is anion. Why? Because it is negatively charged. So let me screen. Screen now. Can you see my screen? Okay, can you see it now? Okay, good. By next class, we will deal with the issue of screen. Okay, good. So, very. So I was something that when when you say an, it means negative charged ion. So as long as it's negative, it is an anion. This one is called polyatomic because it has more than one. It has why it's called poly. So this one now, I call it mono ion. That means only one atom. So mono. If somebody say network is good. Can you guys hear me now? Can you? Okay. So good. I said something atomic or polyatomic means one. Fluorine ion. No, because it's only one atom, which is fluorine. Polyatomic, three atoms, one, two. That means one nitrogen and two oxygen. So let me give you guys more. Who has one? I'm waiting for.
Tanaka quickly on the scene.
I like what I'm seeing. Keep it coming. Genesis, well done. Ugochukwu, well done. Let me refresh my screen. Yeah, Darasimi, your answers are good, but I have a problem with the third one, even though it's correct. Genesis, you are doing well. I like what you're doing. Marianne, that's a good one. Tony George, good. Good. Okay, my students you are now sounding like a chemistry student. I'm now feeling like a proud teacher. Keep it coming. Keep it coming. Yeah, Tony George, that's good. Yeah, Genesis, I said you are doing well. I like your answers. Ugochukwu, good. Marian, good. Darasimi came with sledgehammer. Good, good. Genesis, you can't hear what I'm saying. Marian, good. Ugochukwu, good. My screen, okay. Gina, I like that. I like that. Gina Okereke, I like that. Yeah, Gina, you're doing well. Okay, I'm frozen. I think it's from your side, though. Genesis. Tony George, good. Ami, you came with sledgehammer. Ami, you came with sledgehammer. Yeah, Bukola, ZN is zinc. I hope you guys can see my screen. Let me give the answers. All of you are making sense. Can you see my screen so I can give the answers? Okay, so let me give the answers. This is right. So can you guys see my answers? Yeah, Genesis, you are doing a good job. Can you guys see my answers? I've written the answers. The answers are there. So based on the answers I've given, are you celebrating? I like that. I love what I'm saying. I love what I'm saying. I like that. I like that. Yeah, clock it, clock it, clock it. That's a good one. Okay, so I think I have done a good job today in differentiating between atoms, molecules, and ions. Now, when you see an atom or a molecule or an ion, you know how to differentiate them, right? Marian, clock it, clock it. Yes, that's how to end a class. That is how to end a class. So I'm going to be posting on the group the assignments. Yeah, clock it. I like that. So I'll be posting the assignments on the group. Even though I would have liked to say something more, okay, you know what? Let's discuss one more thing before we go. Okay, let's discuss one more thing before we go. Atomicity of an element. Atomicity of an element. So now listen. The atomicity of an element is the number of elements or the number of atoms that is present in one molecule of an element. Let me write it. So atomicity is the number of atoms present in one molecule of an element. Atomicity is the number of atoms present in one molecule of an element. Now, some elements are what we call monoatomic. Monoatomic means that in nature, they exist as one, like sodium, aluminum, magnesium, especially the metals, zinc. They are monoatomic. In nature, they exist as just one, they exist alone. Now, but some elements are diatomic. Some elements are diatomic. Diatomic simply means, for example, O2, oxygen, N2, Cl2. So some elements exist together. Like oxygen, you can never see oxygen existing as O. Oxygen elements always exist as a molecule, O2, nitrogen, N2, chlorine, Cl2. So those kind of elements, we call them diatomic elements because they exist as a molecule. They exist together. They exist two in one. If you have ever seen love birds, they go anywhere you see one, you always see the other. That's exactly the way the atomic molecule is, the atomic elements are. Then we have triatomic elements. Example of triatomic, you have ozone. The name of this is called ozone. Ozone is a triatomic element. It has 3 atoms in one molecule. Then we have polyatomic elements. For example, sulfur, phosphorus, and so on and so forth. Do you understand? If you understand, say yes, I understand. Okay, very good. Very good. Very good. I'm glad. I like that. No, this is not polymorphism. No, not polymorphism. Polyatomic. Okay. I'm glad. I'm seeing understanding. I'm seeing understanding. I'm happy. Yeah. So, very good. Very good. Very good. Very good. Very good. Very good. So that means you guys are ready for my next chemistry class because it's getting interesting. Polymorphism is outside the scope of this class. Chinelo, I don't know where you are getting all this. Polymorphism is not even a word in chemistry per se. You see it especially in biology, and especially when it has to do with DNA. Well, in chemistry, polymorphism is simply when a compound or when a substance have different forms. I will explain that as we continue. Don't worry, I will explain that. We will still get to that. Polymorphism, we are not there yet. We will soon get there. It's another name for allotropy. We call another name for allotropy, but we'll get there. Okay, but for now, let's take it one step at a time. Or am I too slow for you guys? You guys want me to be faster? Am I too slow? Should I be faster? Genesis, what do you want me to spell? Okay, Isaac, you said you want me to be faster. Okay, no. Okay. I'm only trying to do it in such a way that everybody should understand, at least most people. Okay. Okay, everybody say no. Okay, that's fine. So I'm going to stop here. So I'm going to see you guys in our next class. If you have not liked the video, please go ahead and like it. If you have any further questions, you can send me a message on WhatsApp. You won't have my private number. You send me a message on WhatsApp if you have any questions. This night or tomorrow, I'm going to be posting. This night or tomorrow, I'm going to be posting questions, practice questions, so that you can solidify your understanding. Good night. Good night, everyone. Good night. Good night. See you tomorrow for physics. See you tomorrow for physics. Come early, oh, come early, come early. Make sure you come early tomorrow. Meanwhile, who are the first two people? I think Brian and who should send me their send me a message. Isaac, you're welcome. Brian and somebody else. Is it Genesis? Okay. So Brian and Genesis, send me a message so I can send you your airtime. They were the first to come early today. Okay. Have a nice day. See you guys tomorrow. Bye-bye. You're welcome. Good night. You're welcome. Good night. Stanley, I didn't see you, but good night.